Alright guys, this is a summation video following our survey training on July 14th, 2026. We talked about how to collect data on the Trimble survey grade GPS unit and exporting that to a CSV as well as a shapefile. The key being, if you're working on UTMs, recognizing that that's a meters-based system, so switching your job to meters and then exporting, or if you're in state plane or county coordinates, that's feet-based, and you can export accordingly. So we get a CSV, and we also talked about opening it up in Excel first, and we talked about adding a header, then removing the reference. So the first line was the reference base station, which may be miles away, and then adding point, northing, easting, elevation, and description. And these are all in meters. If not, if you get a file that's a CSV and it looks different, we did talk about adding a northing to and an easting to field and dividing by the conversion rate of 3.2844. Alright, so once that CSV has been cleaned up a little bit, we can simply right click, create points from table, XY, table to point. We want to output feature class. This is going to create a points layer in our geodatabase. This is just defaulting to the geodatabase that we want. So we're going to go sample 2 points end, just for the end of the training. And remember the X field is sideways or east-west, so that's actually easting. The Y field is north-south, up and down, so that's your northing. And let's see if we can get by. Sometimes you can get by without the Z, otherwise. So for the XY, we talked about going to the projected coordinate system. Basically, we want to match what is coming out of the box. So in this case, it's a projected system in UTMs. North America, NAD 83, and Zone 15 North is the standard for Minnesota. Certainly you can add it to your favorites, and then it'll always be at the top. The Z, you want it to match, and just click on it. Looks like it's favorited, and again, this is kind of variable too, depending on what's coming out of the box, but you would assign it based on vertical coordinate system, ellipsoid based, North America, United States, NAD 83. That will let you get past this spot. And now we have points on the map from where we collected them today. Just make them bigger for now. And it's going to have attributes associated with that. Point, northing, easting, elevation, description. So we can do a few things with this. If let's say you missed a few shots in terms of getting elevation data, we talked about using a DEM, digital elevation model. The state has a seamless 1 meter DEM. You can also download the one just for this area. And to do that, basically you just copy and put it in a new scene. Paste that in there, and then go up and use the tool add surface information. What that's going to do is it's going to basically slam the elevation of the underlying DEM to those points. So it may or may not match exactly with what was shot. It's kind of based on the underlying DEM, but it could be enough to fill in the gaps. And you're going to want to make sure you have these elevation surfaces. If it asks, if you don't have these surfaces, you just got to make sure they get basically dragged down from the top into these ground elevation surfaces. Another tool that's helpful, even if you don't have a 3D license, is this elevation profile, which the simplest method is just to do an interactive profile. There we go. So it goes down in the ditch and comes back up. We can export this as a graph, as an image, as a CSV file, I believe. So that's just a bonus that you can do. You can. There's also tools in ArcPro. You can convert this to a line, various things that are more elaborate. Okay, so let's compare, just for fun, how that went. So it added the C column, and pretty dang good. 418.308, 418.307, 418.405, 418.388. These are in meters, but still very close. So it'd probably be just fine in this case if you need to fill in some gaps with some DEMs, assuming the ground hasn't changed in the last 3-4 years since the LiDAR was flown. So then we have our points. You can do with them as you need to. We also talked about exporting a shapefile, and it was a sample2 shapefile, which was in the folder that came out of the box. As it comes out of the box, it's basically got just the foundational aspects to a shapefile, which are the DBF, SHP, SHX. Those three files were what we downloaded out of the box. And so when we add that into ArcPro, we know it's in UTMs, but ArcPro doesn't know where it is. So we're going to define that projection, and then it will add this PRJ file to it. And so simple to do is just define projection. We're basically telling the system we have this shapefile, and it's letting us know it's already defined. But of course, if it just came out of the box, it wouldn't. Then we would just pick from our favorites and assign that. We can reproject that two ways. If we want to get it into counting coordinates, we can use the project tool. We'll put in our input, which is in UTMs. Call it what we're going to. Pick our coordinate system, which will be different. Maybe Beltrami South. The other thing we talked about is you can set the map coordinates, the map properties, to Beltrami South, and if you go to export features, it should pick that. Otherwise, output coordinate system current map, and when you hit OK and export those features, rename it, it will change it into counting coordinates. Okay, so then to go back into the box, we talked about, so let's say we have points that we want to stake out. These are these points to GPS, 3 points. We talked about cleaning up the attribute table. Sometimes the attribute table has a lot of fields, and we really want to get it down to northern eastern elevation description, and and then like a point number in front of it. Click the 3 lines to the right, get the fields view. Its potential, you're going to have a lot of visible fields. I just would turn on the ones you need. And save it, close it, and here we go. And point, northing, easting, elevation, description. If the easting and northing are not calculated, we calculate the geometry on that using this calculate geometry by right-clicking. The northing is the Y, easting is the X, and we can define the format and the coordinate system. So if those are empty, you'd want to basically, this is how the GPS survey equipment knows where to stake out points. We also learned that elevation in this case should be meters if we're working in ETMs. That's what we're sending it back to. I don't think it's going to, yeah, there's no Z value, so we can field calculate that. Oh, there was a Z value from before that we turned off, so we can just recalculate that. Oh, it didn't like that. Elevation. That's probably need to be turned on again. Maybe this version doesn't have it. At one point we assigned a Z value to it. Alright, nonetheless, we will just simply do it manually. 0.3048. Elevation equals elevation times 0.3048. Now we have it in meters. And now with the table open, whatever ribbon we have, we go to our table ribbon up here, export table, points to GPS, yep, and export table, and we could do filters and different things, but that's really all we need. So if we just do this, it's going to make basically a layer called points to GPS export table and stick it in that survey training demo.gdb. So we want to make it a standalone CSV file. In that same folder, but not in the file geodatabase. Hit OK. This is a CSV file that it made, and probably don't need these 3 fields. If anything, we do need a point. 3, northern easting elevation description. There we go. It should go right into the box if we email it or put it on a flash drive.